Hello everyone. I'd like to talk to you today about 12-factor apps in .NET. Just a housekeeping note for the reviewers first of all. I'm going to run the slide deck using PowerPoint directly. It's making it easier for me to transition between the slides and code. And I'm actually working with Google Hangouts. So the first question really to ask is, how many people have heard of 12-factor apps? 12-factor apps have come into the news more recently because of Pivotal, and Pivotal Corporation have been pushing them, particularly with this idea called cloud native. So what I wanted to do today is talk about what cloud native is, why Pivotal might be pushing that idea, and within that, what 12-factor apps are. And hopefully by the end of today's presentation, you'll have a good idea of what a 12-factor app is, when you might be able to use it, why you would want to use it, and how you would go about implementing it when you're using .NET. This is me. I don't usually talk about most of the points on this slide. I'd like to highlight the point at the bottom though, and that point is that just because people stand at the front of the room and speak doesn't mean that they're necessarily any smarter than the audience. It just means that they have the confidence to do so. And I would always urge everyone who's sitting in the audience to think about speaking themselves, to get up and share their knowledge. And even if you think that your peers know what you know, that doesn't mean that there's not information you could give to people who don't know you. Even new developers, we always need talks addressing new developers. So I'd really encourage everyone to get up and speak. This is who I work for. And we do collaboration software for the enterprise. It's not really of interest for this talk. I'm not a consultant. I don't have anything to sell you. This is really based on our experiences that I've come across doing this work. And I'm an architect at Huddle, and we've begun to use many of these ideas. Okay, let's talk about the agenda. The first thing I want to do is really set some context for 12-factor apps and cloud native. I then want to talk about the origins of the idea, where it came from. It predates the cloud native push, and I want to talk about where it came from. It's insightful as to some of the ideas behind it. I'd like to talk about the goals of cloud native. I'd like to talk about what we hope to achieve by using it. And then I'll talk about the 12 factors themselves. Now, rather than simply run through all of the factors one by one, what I've done is divide them into three major groups: design, build, and release and manage. I'm going to talk about them in context in those groups, and hopefully I'll be able to give you an idea of how using the factors affect each of those stages of the software delivery lifecycle. Some housekeeping here. I upload all my presentations to my GitHub, and you can go and download the slides from there, particularly if you're in the back of the room and you're struggling to read the slides. And I also upload all the code. We're going to look at some code today, and you can go and look at the code there as well. We won't run through all of the code in this session, but it's an application you can go and download afterwards and look through and run yourselves, and then get to play with some of the ideas that we're actually dealing with in this session at your leisure. Okay, so let's talk about the context first of all. Why would you care about 12-factor apps? So as we mentioned before at the beginning, 12-factor apps are one of the pillars of cloud native. So what is this cloud native idea? Why do you care about that? Well, maybe the first thing we need to actually ask is not what cloud native is, but what cloud is. And there's a very particular definition of cloud we want to use as part of this presentation. And that's that cloud is on-demand and self-service computing network and storage. And by that we mean that it's very easy in the cloud for me to simply say, I need a new instance to run my web server. I need a new instance to run a worker process. I need to scale out the worker process by adding more instances on demand. And that elasticity, the ability to elastically increase the capacity of our application, is a key feature of cloud. It's also important to understand that that feature is revolutionary because it's available without upfront capital investment. You only need to pay for that elasticity when you have the demand that requires it. And so when we think about that definition for cloud, we can think about an application being cloud native if it's designed to run in that on-demand elastic environment. But more particularly, if the application can exploit that environment. In other words, your applications can scale in an on-demand and self-service fashion. When we talk about cloud native, there are a number of maturity levels that people like to think about. Beyond this, essentially, if you like, at 0 in the maturity model is lift and shift. That is, I take an existing application that lives in a data center and I just simply put it straight into the cloud with no transformation. So my compute instances just become EC2 instances in AWS, as an example. And I just put my database and eventually just shove something into RDS. But my overall model looks exactly the same. I've made no effort to cope with the fact that I'm now in a slightly different environment, that I'm no longer hosted on a rack, that I may be hosted in a number of availability zones that could have a higher latency between the portions of the rack do. And so what I may then choose to do once I'm in the cloud is go through a series of steps to make my application run better in the cloud. Ready would mean essentially I recognize the fact that the resources on the individual compute instances are not suitable for use in my overall cloud application. I want to avoid local disk. I want to store things instead in S3 storage because of the ephemeral nature of those items. Beyond ready, I might go to friendly. And friendly is really the area where we're talking about 12 factors. When we begin to think about being able to exploit the cloud's ability to scale on demand. When we get to resilient, we start to move to the area where we're starting to worry about the availability concerns that would come with working in the cloud and coping with them. Chaos engineering, chaos monkey comes in this phase. And finally, cloud native, we begin to think about microservices and API first design. So really, when we talk about 12 factor, we're talking about things that help us become cloud friendly, a key step towards becoming cloud native. But we should also remember they do cover the ideas in cloud ready. But if you're not in the cloud, you may say, well, it doesn't concern me. I'm not in the cloud, so the 12 factors are pretty useless to me. But they're beginning to see growth in other areas as well. When we think about containers, so Docker and Kubernetes, for example, we're also thinking about using applications in a self-service, on-demand, and elastic fashion. In other words, self-service, we simply write something like a Docker file or a Kubernetes file or a Docker Compose file. And we use those to produce instances of our application. And we use elasticity because in Kubernetes or Docker Swarm, where we are able to scale by introducing new container instances. So the principles that in 12 factor are important to us to work with a cloud are also very useful when we're working inside containers as well. And the one thing I want you to focus on is this idea, basically, of we're enabling our apps to be elastic. We're enabling our apps to basically increase to meet demand without really rewriting them to do that. Okay, so I'll take a step back and we'll talk a little bit about the origins of cloud native, where it comes from. And it comes originally from Heroku. So Heroku were a polyglot PaaS platform. Originally, they were focused on Ruby on Rails, but later they began to move to export other languages. And the Heroku team began to look at guidelines to issue to their customers for what would make a successful application on Heroku. And in particular, the co-founder of Heroku, Adam Wiggins, wrote this paper called the 12-Factor App, which discussed the key items that wouldn't be necessary in order to succeed in that kind of environment. And he came up with a number of principles that we will review more at the end. But essentially, you should be declarative so that you automate fast. When new developers join the team, they should be able to rapidly spin up the application and begin testing. Have a clean contract with the underlying operating system. And by that, we mean we want to minimize our integration with the actual operating system we're running on. We want to be able to move between environments very easily. We want to avoid the need for systems and service administration. In other words, we want to basically be able to not stop worrying about things like regular upgrades to our servers. And we want to essentially have as close an environment in development as production. Now, traditionally, that's been cost and effective, but in a container and cloud environment, that is possible. We want to be able to scale up without significant changes to the architecture. These are lofty goals, and what I hope to show by the end of the talk is how 12-factor helps us achieve that. All right, so we're going to talk about the 12 factors very, very briefly, but we're actually then going to just dig more into them. So these are the 12 factors, and you can see I've color-coded them. Blue are factors essentially that are important when you're thinking about your build stage. Factors in green are the factors that are important when you're thinking about your design stage. And the factors in red are important when you're thinking about the management phase. We will run through all these and review them at the end, so I'm not going to try and itemize them all right now. So let's talk about the design phase first. When we're actually building our application, what constraints can we use that will help us as application? Okay. The first constraint we want to talk about is port binding. So one of the constraints in 12-factor apps says that our application should run by exposing a port and nothing more. So if I'm going to run, say, for example, a web server, when my application runs, it simply says, I'm going to basically talk HTTP over this port. Okay. And it may be that you have multiple processes running in your application, and that you're not simply just talking to the end user via HTTP, but you're talking to other applications. And they are simply a URL that you talk to, which itself effectively has a port that you are actually addressing. And it may be HTTP, with those other applications, you might also be talking TCP, IP, or AMQP. And if you think about serverless environments like AWS Lambda or Azure Functions, what you'll recognize is that the code you are writing is always essentially listening to an endpoint. It's either listening to a port, it's listening to some event raised from the system. And that is all your code essentially in this 12-factor app model should do. It should say, I don't care about any kind of hosting environment that I'm actually in beyond the fact that I just simply listen to that port. And what you want to avoid is a more traditional model where we may run an application service such as IIS. Okay, so I want to talk about IIS briefly just so you can understand why you might say that. So this is IIS, and as I'm sure most of you know, what happens is essentially that a request comes in from the end user. It's dealt with by HTTP sys, which is a kernel level component of Windows. And then what happens is that the Windows Activation Service looks up what application is configured to handle that request. It then uses the World Web Publishing Service to activate that by running a worker process. And the worker process is essentially a sandbox within which your application runs. Now, what happens is that a given application pool maps in most instances to a worker process, but you might actually have an application pool with multiple worker processes working inside it if you're deploying as a web garden in order to create performance. But generally speaking, the idea is that your application container manages a number of sandboxed instances of your application. And by sandbox, we mean a failure in one instance shouldn't impact the other instances. And the idea is we can use this to get the most value out of our given underlying machine. It's what we call utilization, the idea that I want to use as much CPU as possible on the machine, as much memory as possible on the machine, so I'm not paying for resources that I don't need. But today, increasingly, we run applications in a very different way. This is Docker. And in Docker, essentially, we have a Docker host, which is the host operating system, and a Docker daemon that runs on that system, which essentially allows you to send commands to the host from the Docker client. Those commands be things like Docker run, Docker exec. You have a Docker file, which essentially allows you to configure how you will essentially create containers in the host. And what happens is the Docker daemon reads an image from the registry, applies another subsequent layers that you define on top to create your application, and then runs it in the host as a container. In this model, the container is now the sandbox containing your application. And your application, if it fails, won't impact other containers running on the same host. And you can see this is a very similar model to the one we are using traditionally with IIS. IIS is an application container, and Docker is also really an application container. And thus it makes no real sense for us to run IIS inside a container. We're running containers inside containers at that point. And as we move into the modern environment, where increasingly you'll begin to see containers as the new deployment vehicle. Amazon, for example, is very likely soon to offer containers rather than instances. And I'm sure many of you have seen that Kubernetes is rapidly becoming the new deployment choice, replacing things like Chef, Puppet, Ansible. As we move forward with that model, increasingly the model you are trying to think about is my app is just a container and it listens on a port. In addition, it's important to think about backing services as attached resources. And what we mean by this is at a very basic level is that I may be talking to a database via a connection string, maybe talking to another service that's part of my application via its HTTP via REST, or perhaps via basically a message broker using AMQP. But also that some resources I may traditionally have felt free to access, such as the local disk, or essentially storing things in memory between requests, are no longer things I can rely on. In a container environment, and serverless environments are implicitly container environments, then I would find that my disk is not necessarily available between requests, and my process memory is not necessarily available between requests. Serverless, for example, uses a pool of containers to serve your request, and there's no guarantee that the container you get will be the same container that you used last time. And so increasingly it's important to understand that anything you rely on outside of your actual process memory, such as, for example, a file system, needs to be something you are obtaining via basically a connection. It's a service. So you need to think about using S3 for storage instead of local disk computer instead. If you try and access local resources on the machine, you are not moving towards that cloud native model. Okay, let's have a little bit of a demo. I'm going to spin up basically some code here first of all, and I'll show you it running. Okay, so this is essentially a app I've written that is probably the most sophisticated Hello World app that's ever been written, or most over-engineered Hello World app that's ever been written, depending upon your perspective. And what it consists of is basically here hang on a minute, just a note for the reviewers. I just need to switch out, so not to set this up correctly for this. Let me just do this. It's not something we'd actually be doing during the presentation. My apologies to the reviewers for having to switch around. We have a number of branches and I am on the wrong branch. That's for the start of the session. So that should just switch us over, and I just need to get into the relevant directory to run the code. So you just bear with me. Apologies again. Okay. Right. And shut that down. We just see the code memory remembers everything. And up again. All right. Thanks to the reviewers for just bearing with us while we worked on that one. Okay. So we have a greetings app. And the greetings app essentially is just a typical ASP.NET core app. We have a controller, and the controller essentially just lets us do a number of operations. It lets us essentially post a new greeting. So by posting a greeting, you post something like hello world, hello Ian, hello Mary, hello Bob, hello Alice. Now you'll notice we're using something here which essentially is just a CQRS framework called Brighter. And we'll show you how that works in a second. But we create a command, we send it over a command processor, and that just essentially is going to go away and store a new greeting request. If we look down here in our core, we can see where it's going to do that. And we're just essentially going to use an entity framework core to save that information away to the database. Okay. In the controller as well, we can just do something similar to actually go and get that information back. We've got to get here. And if we look down here, we'll find the handler for that particular item. And again, fairly straightforward. We're just creating basically an entity framework unit of work. We're going away, finding all the result sets and turning them into something we represent basically back to the user via REST. And what's perhaps of interest enough, we are async, and we are async all the way nowadays with a modern web application written in ASP.NET Core. Okay, that's a very brief overview of this application, but more interesting perhaps than any of that from the point of view of the 12-factor app is you'll note we have a Docker file in here. So what we're actually going to do is run this application using Docker. This is a very simple Docker file. We simply take the off-the-shelf .NET Core 2.0 image, just take the one provided by Microsoft, and we copy our code into it. One of the things we need to do first before we do this is actually to build our source code, because we're going to build it to an out directory using .NET Publish, and then we're only going to copy the built artifacts into the container. We'll then build the container and run it. Okay. And in addition, as well as essentially our web app, we're going to need a database. This is a Docker Compose file. And what Docker Compose file lets us do is run multiple containers at the same time when in the Docker host. And all we're doing here, as you can see, is setting up MySQL, which is a database. We use MySQL rather than SQL Server for Linux only because the memory footprint is lower from the point and is therefore easier to demo. And you can see that the web container is going to depend on MySQL. What that means is we're going to spin up MySQL as well as the web. Okay. We'll note some environment variables are being set here. Don't worry about those for now, but we'll talk about that later. Quick note for the reviewers, that particular folder is empty but shouldn't be there. I will remove that. That will simplify the code. Okay, so what I'm going to do now is go over to my command line. Let me just increase the size for you a bit. Okay, and the first thing I need to do is to just make sure that I've built this and a .NET Publish on it. So I'm just going to run a little shell script I've got here. Now this is essentially a very simple build. It's working with MS Build and solution. There's no cake or fake here. I like to keep my build as simple as possible because that makes it easier to onboard people into the application rather than learning complex build tools. It will wear away for a second or two and just build this particular application. The advantage of us doing a .NET Publish like this is we don't have to have the SDK installed on the container. We just actually need to have the runtime installed on the container. And that keeps the footprint of the container low, and it also minimizes any risks we may have from exposing the SDK in terms of vulnerabilities to basically attacks. Okay, now I've built that, I can just run Docker Compose here. Run Docker Compose will bring up both the web container, and it will also bring up the database container, so we better run against it. Now, Docker is simply creating the layers of our container here, takes the base image and applies our stuff on top, and you can see it's now running the images. If I use Docker PS, I will be able to then see the services running. Now you notice that the database says its health is starting. I need to get that to healthy. And so I may have to run this a few times. Now, generally speaking, what your code would need to do is code with the possibility that the database is not up yet. It takes about 30 seconds usually. Once it says healthy, we can actually run some code against it. But you have to wait until it's healthy. There we go. So this is healthy now. Now what we do with Brighter, by the way, which is an open source library I work on that we're using extensively in that model, is we did that for RabbitMQ. We actually check RabbitMQ is up and running before we move on. Okay. So now I want to actually demonstrate that this works. So what I'm going to do is essentially fire some web requests at it. So the first thing I'm going to do is send basically a GET request. This is, by the way, I'm using REST client in Visual Studio Code, which is very handy for being able to see working with the REST API. Okay, and as you can see, it's come back and said okay, and there's nothing in the list as yet. I took 821 milliseconds. Now, if I do that again, you'll probably find it's a lot faster, 77. That's because essentially, when I hit basically that endpoint for the first time, obviously it's going to do some compilation in the background. So now I'm going to add a greeting, and I get the response back saying this greeting is being added. My list of greetings added. So let's add a couple more greetings in. It's Mary and Alice. Okay, and now I'm going to send a request back, and you can see I've got a whole set of greetings being added into my database. Okay, and what we've managed to achieve there is essentially a very quick, simple application that has allowed anyone who joined the project to immediately spin up and start playing with their application. There's no cost to them to basically have to go and install MySQL, no cost to them to try and deploy it locally to the website. One other thing that's worth noting is that or anything like that. So the reason we look at is we're just running straight on Kestrel. .NET Core essentially is that it's very good at supporting the kind of model that we need. So if I look in the program file, you'll find that I'm running basically using Kestrel. So Kestrel is a lightweight web server. So it enables us to essentially send and receive web requests. It isn't a full weight web server. It won't do things, for example, like terminate SSL. So we need to basically put something in front of it like Nginx. We're not going to cover that in this talk, but you do need to basically think about that constraint. You'll see, notice here, we're just basically saying we're going to expose this application on a port. And that's the important thing. We are self-hosted. The host is then running. And the host is essentially saying, I'm now listening for requests on this port. And that's one of our key constraints, port binding. You'll also notice we're using environment variables. We'll talk about that again later. If we go and look at the configuration, you'll see at the setup of this particular item, we're using a facility within .NET Core to use environment variables to set essentially the database connection strings, etc. And if you go and look at our Docker Compose file, you can see that we're actually setting the connection string information we need for MySQL here. You can also see that we're mapping the internal port we're exposing to an external port on localhost, such that we can actually expose ports to the host operating system, not just basically Docker host itself. Okay. Now, the next thing I want to talk about is processes and concurrency. So one of the key ideas behind a 12-factor app is that we should execute the app with one or more stateless processes. What does that mean? Well, the first thing is that our app should be stateless. In other words, particularly for a web server, we don't want any sticky sessions. Don't mean we have no notion of state. We can store state in a database, for example. So a better term is sometimes state aware. What we do mean is that we don't want to store session data for a given user in memory on a web server. And the reason that's a problem is because the user then has to be sticky to that web server. And if a user always has to come back to the same web server, then we have a problem with essentially scaling to demand, because it's impossible for us to move that request to a new web server. It also creates a problem if the web server that the user is currently going to is one we want to take out of service for some reason, or just fails, we can't move the user to the next request. So the state should be stored in the backing store, or if we're using something like REST, actually the request response itself may well contain much of the state that the user needs to worry about. We should really only use memory or file system for the application in the event that essentially it's just per request, so for that single request. Think, for example, of the situation you'd find yourself in if you were using, say, AWS Lambda or Azure Functions. What happens there is a container is being, running your code is being given to you from a pool of containers. So there's no guarantee that the user will get the second one the next time around and be able to access anything you stored in the local file system or essentially in memory. But in addition to that, the other thing we want to think about is dividing up our workload. So we may have a workload of HTTP requests that we can handle quickly, and we can deal with in, say, under about 250 to 300 milliseconds. That's the magic number. And if we can deal with a web request in that time frame, we can probably continue to turn over requests fast enough that we can scale our web servers. When it takes longer than that, we may want to think about doing the work asynchronously, handing the work off from our web process into the user to tell them we have the work, usually with the 202 accepted. And the 202 accepted, we usually give back a link. That link says, go to this endpoint. And on that endpoint, either we have some progress tracking information, or we have the actual resource itself that will return 404 until basically it's ready. In the progress tracker, we usually use a redirect to actually move to the final resource when it's ready. When we take that work, we want to give it to another process to handle. Now, generally, the way to guarantee this work will be done is to use a message queue. We put it on a message queue, and the nice property of message queues is that they're guaranteed once and once only delivery, or at least once delivery. And the message queue, a separate worker process, consumes work off that queue and then is able to essentially deal with it at whatever rate we can manage in terms of the number of resources we can allocate to it. So it's a great way for you to be able to do work a little bit slower than the rate of it coming in, if that work can be handled asynchronously, and reduce the burden on your application in terms of the need to scale out rapidly. So at Hubble, for example, we do this all the time when people upload content to our application, maybe, for example, video that we want to convert or a document we want to convert between Word and a PDF in order to preview it. We'll hand that work off to a message queue, and then worker processes whose job is to basically chunk through that process of doing the conversion will pick up the work as it comes in. We only need to therefore run a certain number of those servers to cope with normal demand. And we don't have to worry about a sudden flurry of activity or a particularly large file coming in and blocking that web server while it processes it. And this is a kind of diagrammatic representation of that model. You can see essentially you have tasks coming in, requests to a variable, placed on a queue, and then we handle the back end of the service. And we just discussed this idea essentially that we put the work on a queue and we have a consumer read off the queue us to deal with peaks of demand by processing it essentially asynchronously. Okay, look at doing that. So what I'm going to do now is switch to another version of the code. So you'll notice when you get this code yourself and look at it, we have a number of branches. And in the first branch shows the simple website. In the second branch, what we do is choose to basically have a worker model as well. And again, what I need to do is just reload Visual Studio Code, tell Visual Studio Code that the application has changed. Okay, so our application looks like it did before. We have greetings app, etc. up. But now what we'll find we have is a worker process. And in that worker process, we are essentially, don't worry about the complexity here, but we are building essentially a dispatcher. So the Brighter OSS library. And the dispatcher says, essentially, I am going to read from Rabbit, called greeting regret command, anything that essentially has this topic. We just use the same key name as the topic in this particular case. And we're saying, I want to subscribe to messages sent under that topic. When I get them, I will route them basically to a handler. And the handler that we're going to route to is defined to us by the application as well. So we're going to route this to a regreet command handler. Okay. So we're looking greetings.core. I can find essentially that handler. Now, we're going to do something a little bit lightweight, which is just really to print out a message so that we can go and see the message was received very easily from the logs. And we'll show you how that works in a second. What you'd actually be doing is something much more heavyweight here. So you might be, say, for example, sending that information to a third-party application, and you were worried about the cost of making an HTTP call to application might not respond, or you'd be doing some heavy processing. But for our purpose, to see it clearly, we're just going to push it to a console. And finally, the other change we've made is we need to send that message in the first place. So over in the web application itself, in the controller, you'll notice that when we post, we've added a line here now. We should have added a line here to post that work. Let me find out why that is not happening there. So there should be a line to, okay. It's actually, sorry, apologies to the reviewers. In the command handler, we've added a line to post. And so after we've actually added the greeting into the repository using the entity framework code we showed you earlier, we're now going to post a message onto the queue to say we've added that work, and it will then do its work and do the regreet for us. Okay, so what we need to do is need to rebuild the application because we've added new code in here. And again, just to remind you, the reason we're doing this is what we want to do is make sure we don't have to deploy the SDK out to the container. So to do that, we want to basically use .NET's ability to build the actual application before we deploy it. And so we don't need to deploy things like MS Build, for example, out to our container. And so here we're just using .NET Publish. We're publishing to a known directory out, and we'll copy the contents of that directory once we've done it over to the container. So that's just building now. And you can see that as well as the greetings app and the greetings work, we've also got the greetings, or as well as the greetings app from last time, we also now have a greetings worker. Okay. That should finish in just a second. Right. So now that that's done, what we're going to do is just use Docker again. And maybe worth pointing out that in order to do this, we also have to update our Docker file. So a Docker file is going to have a worker. We'll come back and look at that in just a second. Let's get Docker spinning up in the background because it can take a few seconds to build everything. Oops. Okay. While it's building, what I want to show you is that as well as the web, we now have a worker process, a worker container. And as you can see here, it as well also defines a number of environment variables, and it's just built from the actual code, but it also defines dependency on Rabbit. So Rabbit is RabbitMQ, so we're using RabbitMQ as a broker. It's giving us the ability to create a queue between our two applications. It's just a standard Rabbit image provided by Pivotal themselves, which are basically the people behind RabbitMQ nowadays. So we're just pulling down their standard image, exposing basically that on a port, and we can then talk between our web and worker process using that port. And again, MySQL is as before. So a real advantage here when we're talking about the ability to have on-demand self-service architecture is this fact here, we can just do the very short number of lines, pull in an existing image. Okay, so Rabbit's stopped working on my machine. The reason for that is I already have Rabbit working on this box. I need to stop Rabbit, and then I can restart Docker. Okay. And what we'll find again is we need to basically have a quick look. Okay, so the database is up and healthy, so we should be fine. Now, what we're going to do is we're going to send some requests again. So this time around, when we launch the database, we'll find there's some existing entries in there from last time. So we're just going to add a few more new ones. We'll get some repeats in the list. Just add them a few times, just so you can see a bit more of a list. Okay, and when you see the list now, you'll see we have a lot more items. Okay, that's not interesting in itself. What I want to do now is go and look at the logs for the worker. So in Docker, I can do Docker logs and go and look at the logs that are being generated on a given machine. I can do is copy the container ID for the worker process and put it there. That will then let me see the logs. As you can see now, I've got a whole set of logs, much of these generated by Brighter here. But the key item here is you can see that I've actually got a printed out message from the regreet command handler saying, hello, Alice, which I think from originator follows. So here I have basically my application working. So I am able to get that working by pushing the work across the queue, and you can see effectively that the user is able to essentially push that work to one side. So you can see we're scaling out by that particular model. Okay. Scale up with the process model. The only thing really to say here, in addition to other items, is don't even use the operating system's process manager. So really, this is an admonition on the Unix side against essentially building your processes as Unix daemons. The idea is to use something like supervisor D, etc., to manage your processes instead. Within the world of Windows, our equivalent really is a Windows service. The problem with Windows services is not cross-platform. So generally, in the 12-factor app model, what you really want to do is write your applications as console apps. And don't forget, essentially, we are self-hosting even our web application within Kestrel. So write it as a console application, and then you can manage those console applications. Generally, if you're to something like Docker anyway, you can Docker itself will effectively manage that as a process if you just simply use something like entry point. Entry point is a Docker command, which essentially says this whole image is being run as an executable. Okay, and the other final point is that in order to make this elastic, what we're going to need to do is make sure that when we start up either a web or a worker process, they start up very quickly and they shut down slowly. And the reason for that is if it takes us 10 minutes to start up a new web server, or it takes us 10 minutes to start up a new worker, we're not going to be able to respond rapidly to a peak in demand and provision new resources to meet that peak. The peak will be over by the time our new resources come online. But we also don't want to be paying for those resources at a time when essentially there is no peak. And so we want to be able to basically turn them off very rapidly as well. That is the definition, if you like, of elastic scaling. And it's important for us to be able to do that work. So you can see here, there's a common pattern called competing consumers when we talk about using a task queue. We have a lot of work placed on the message queue. And at the end of that period, what we want to do essentially is rather than use one consumer to read off that particular queue, we might want to use 2 or even 3 consumers to read off that queue. If I've got a lot of video to process there, I may find that one big video blocks the entire queue if I only have one consumer. So if I have 2 or 3 consumers, well, one of them is working on the first large video, the others can begin to eat through the rest of the queue. Now, we can demo that quite quickly. So let me close this down just so we can clean up the response. So what I'm going to do now is I'm going to basically Docker Compose again to run, but what I'm actually going to do is say scale, and I'm going to scale my worker to have 3 of them. The worker name just comes essentially from what I defined in the Docker Compose file here. I define this as being worker. What I want to do is scale up to have 3 of them. Docker knows, by the way, essentially to just add things to what I've got already. And you can clearly see here, essentially, that as well as the first worker that I had before, I've got a number of other workers. Okay, so now, if I run my code again to add, say, Mary this time, and that was the last one we had, so I'm trying to avoid being confusing. Okay, so add Mary. Now what I want to do is try and see, well, where was that processed? So again, I can Docker PS. Have a look in the first worker. Docker logs rather. Okay. There doesn't appear to be a process there, so I can have a look at the second worker on my list. bit in process there. As ever with these things, demos, it's the last item then. And then you can see hello Mary. So we try that again. Let's try Alice this time. Okay. And so first, okay, not that one. Let's try that one. Okay, and you can see it's now talking to Mary. So you can see how easy it was for us to scale. We were able to scale by the simple process of adding an attribute basically to Docker to say, I want to scale the number of workers. Now, obviously, if you're in a different environment, you're in, say, for example, the cloud, you've actually got a different way of doing this. But you can see because we had this simple approach of saying scale out using the process model, it was very easy for us to figure out that just multiple workers reading the queue would be an easy way of us scaling out the process. Okay. So after the design part of the conversation, let's talk a little bit about build and release. The first thing to appreciate about the way that we want to work is that we want to have everything inside a source controlled repository. And that what we want to do is simply say that one 12-factor app has one repository. All of the code that we require should be in that repository. Okay. And you can think of a deployment as building that repository and then deploying the code out. Now, there are a couple of concerns people have. What about if I want some code that I'm actually going to share between various parts of my overall application? So an overall system may include multiple apps. That's one thing to understand. If I have a more complex item, so microservices, if you like, are apps. And so in a microservices application, I will have multiple microservices rather than one monolith. So what happens if I have code I want to share between those individual microservices? And the simple answer really is that rather than putting in, having a shared repo to contain all my microservices, what I do is create a repo that has that shared code and use my language's package manager to do that. So effectively you use NuGet to share the code between your various microservices. The other question that always comes up is, if I have this microservice, can it have more than one process inside it? In other words, can it have both web process and worker process in it? Or my web process and my worker process both individual apps? So if I go and have a look at the GitHub code for 12-factor apps, just need to bring that down onto the viewing. Give me a second. So apologies for it appearing on the other screen. Just bring that across. There we go. You can see, let me just go to one of the branches that make more sense for you. You can see that in this branch, for example, I've got both my worker process and my web process. Now we do that because we're choosing to say it's all part of the same microservice, and thus essentially it is sharing the model. It has one database, and if you go and look at the code that we wrote for the regreet handler, you will notice that the regreet command handler simply retrieves the greeting from database. We don't pass that across in the message. So where two processes are closely aligned and actually working on the same model, and you simply put them into separate processes for the purpose of scaling, not because they do a different thing, to my mind, it's quite acceptable for those to be part of the same microservice. We get to hardcore this idea of autonomous component. And in that case, I would always include them in the same repo, because to me, the repo is the unit of build and test. And I would want to build and test all these items together because they share a model and therefore changes to the model impact all the consumers. I'd only make the web and the worker separate if they didn't actually share the model. Okay. Moving on. So what we're going to do a quick demo of is a clean application where we're going to pull down the code. So I said that I felt that it was important you saw the demonstration that we, as a new developer on this particular project, would be able to get up and running very, very quickly. What I'm going to do is go to this directory. I believe I have one here already. Let's just kill the existing copy. Okay, that's gone. They won't worry about the backup for now. Okay, so what I want to do is go to GitHub, and I'm going to clone that directory. So I want to go get a hold of a different branch, I think. So let me just go and get hold of, well, it doesn't really matter actually. So I'll go on a master. Whoops, so Daisy. Let's just grab that one. Let's basically talk about the tutorial. Click on download. Let's copy that. Right. So what I want to do is clone this down. So that usually takes a couple of seconds. And while that's happening, so the idea is I've joined the application and the team is a new developer, and I'm trying to cope with the usual thing that first hits nearly any developer basically is that I join the team and I have a lot of work to do to get up and running. So what I want to do is make that as quick and painless as possible. So under my 12-factor model, I'm going to check out my repo. Now I'm going to switch to the branch one you just seen. Okay. Now I'm in this branch, essentially. I can see the code, and what I want to do is just run the build script that I gave you before. This is a new build against this particular item, so it'll take a few seconds longer. So it's going to go away and restore packages. So .NET has a phase in its build process, .NET restore, which says, I have all these dependencies, and I explicitly declare them in the CS proj files and manifest my dependencies. I want to go and get those. Okay, so I'm grabbing the actual dependencies I need, and then I'm doing the build. Having built that, I should then be able to run it. Let's give it a second or two to finish building. What I'll be able to do here is then use Docker Compose in this directory to run this version of the code. Better see that working. The idea is that what I'm trying to demonstrate to you here is how quick it is now for you to get up and running. You built the code, you're running Docker Compose, you're getting the code, the containers up. Any second now, you'll be able to see the containers running. Okay. And now we can go in essentially to our test code, send a request. Right, and we're just doing the same thing we were before. We're doing this now against the code we just built fresh. Oops, I got an internal error there. So it's just clicking on something that's not actually got a. That's a. I need to provide the GUID for that particular item. I won't do that. So click on that by accident. But you can see that we're pushing requests back and forth. You can see how fast that was, and you can imagine as a new developer joining your team, you'd be thinking like, "Well, this is great. I can get up and running very rapidly. I can become productive very rapidly." Okay. So dependencies, we talked about this just briefly when we were going through. Generally, the idea in 12-factor apps is that all your dependencies be managed from like a package manager. I want to be able to take an image that essentially has just the runtime on it and deploy my code to it, knowing that's a clean environment without any other concerns on it. if you've done your Python programming, you'll know that Python has a model called virtual environments, where effectively you can create an isolated Python deployment with only the libs that you care about for your application. In a sense, Docker kind of replaces that kind of model and says, well, here's a container. The only things installed in this container are what you want. And so it starts just the runtime, and then you install everything you need. And that means you're clean, it means you understand the dependencies that you have. Okay, so we just demoed that. Configuration. So this is the admonition within 12-factor apps. Do we want to store our configuration in the environment? What do we mean by that? Well, a lot of you maybe, like us, we used to be at Huddle and have build scripts whose essential purpose is to merge in tokens for environments that contain secrets or contain configuration data specific to that environment, such as basically where particular applications are located or connection strings. And your build process consists of taking the source code and then essentially creating those config files for every single environment. The danger there is that that configuration information is not correct in other environments or changed somehow, and you get failures in production simply caused by the failure of that process because it wasn't picked up in testing. What we want to do is ship an immutable artifact. So we want to ship the running code for our application. If we have any config file data, we want it to be things like binding redirects that affect how we run the application, but are not specific to an environment. And any data that's specific to the environment we're running in, local, staging, dev, QA, production, is provided by something that can vary by environment. The simplest model is to use environment variables. And you could see in the code we were looking at earlier, where we were looking at our Docker Compose file. Docker Compose file, we were defining the environment variables that our application was going to pick up. And you can see within our application itself, in a number of cases, we're simply going to go away and grab the configuration data. So here we're basically grabbing the configuration data and saying, I want to go and look for that database and see if it's up already. Okay. Now, there are some issues with storing configuration data in your environment to do with stack traces or reading secrets. So quite often that is, it's common to use something like Console or Vault to actually store that information at runtime. And finally, what we're talking about in that particular stage you just saw is you want to strictly separate the build and run stages. So the build stage, we create an immutable artifact, which we know is the same artifact that's going to propagate through all of our environments into production. Okay, and the run stage, we want to configure how it runs in that particular environment should be entirely separate and handled by something like environment variables. Okay. So what I want to do quickly now is just review. We said earlier on that we wanted to meet these set of 5 objectives when looking at 12-factor apps. And we can see now how decorative formats, such as basically using Docker files and Docker containers, help us basically manage onboarding into our team. We have a clean contract with the underlying operating system in that we only use basically port information to listen to. We're self-hosted. We run as a console application. We're not baking ourselves into a particular operating system, our Windows or Unix, for example. And that Docker file is a very clean representation of that. We are suitable for deployment on modern cloud platforms. And using the approach of managing our environment variables means that and using even containers, will help minimize that divergence between our local environment and the actual production environment. And you saw us scaling up, particularly you saw us scaling up worker processes. These are the 12 factors again, which we can read through. But note essentially, therefore, we have the tracking of a code base, declaring that dependency and config, etc. The 3 I want to talk about are actually the 3 at the end. So what we haven't talked about are 3 of these items. One of them is keep development stage in production as similar as possible. This just simply means don't alter your code in production. But also it means don't have too long a time window between code being developed from the developer's local environment and you actually deploying that. That long window makes it difficult for developers to have to think about a different version of the code to the one they're currently working on. Treating logs as event streams. Because I'm running essentially a console application, often in a container, then the local file system is not an appropriate place to store logs. It's ephemeral, it may vanish. In addition, if I'm running a microservices environment, I'm going to have huge numbers of places to look for logs, And if I'm scaling up a process by introducing more instances, I have huge number of places to look for logs. Just simply log, standard out, and then use something like the elk stack to pick up that standard out based logging and store it in a database for you to review later. Running admin management tasks in one of our processes is the idea essentially that we have one repo. So if I have admin tasks like database migrations for that particular application, I should co-locate them in the repo with the code they're applied to make sure that when we're changing that code, we don't forget to go and look at the admin tasks that we have. I particularly, in this case in .NET, recommend building a lot of those tasks as basically .NET CLI. Okay, great. Thanks so much for listening. I hope you have some understanding of why you might want to use 12-factor apps now. And thank you very much. Note to the reviewers, yeah, I mean, I spotted a couple of little things that I got wrong in delivery around switching between applications, and obviously I need to make sure that I am fully prepped for the talk when we give it. And yeah, there are a couple of tweaks probably to how I present the code, but I'd be grateful for your feedback and be able to apply that. Thanks very much.